sector including the food processing sector. As the global population keep on increasing, it is very important to adapt the processing machinery and then address the challenges posed by the post-harvest and climate change. Adapting food processing machinery for the climate change involves several considerations. First, optimizing energy efficiency is very crucial for reducing the greenhouse gas emissions. Second, incorporating sustainable materials and technologies can help minimize the environmental impacts. Additionally, enhancing equipment resilience to withstand the extreme climate changes, this is extremely important. Lastly, implementing smart technologies and data analytics can improve the production and help us in reducing waste. By embracing these adoptions, the food processing industry can not only contribute to the sustainable future but also ensure safe and nutritious food for our future generations. So today, with this particular session dedicated on the machineries, we have the expert. I would like to invite our eminent speaker, Dr. R.T. Patil, to please join on the stage, and Dr. Ananda Ramakrishnan to please join on the stage. So a huge round of applause. So audience, huge round of applause. I think we have a very eminent speaker who have traveled all the way and we have present to share their ideas. So let me have the privilege of introducing Dr. R.T. Patil. Dr. R.T. Patil is a distinguished figure in the field of food science and technology. His significance has been significant contribution in the field of research, academia and industry. With a wealth of experience and expertise, Dr. Patil has made a remarkable strides in advancing food processing technologies and promoting agriculture innovations. Dr. Patil so far has developed 16 research prototypes, 5 process protocols, 3 pilot level technologies and contributed to 2 US patents. He published 98 papers in various national and international journals, 57 presentations in various national and international seminars. As a former director of ICRC-FED, he has played a pivotal role in spearheading the research initiatives aimed at enhancing the post-harvest management and processing of agricultural produce. Under his leadership, ICRC-FED has achieved numerous milestones leveraging cutting-edge technologies to address the challenges in the food processing and preservation. Dr. Patil is a visionary leadership. His visionary leadership and strategic insights have not only propelled these scientific advancements but also fostered collaborations between academia, industry and government bodies to drive the agriculture development and food security initiatives. He also served as an advisor to the Tanusha Food, a prominent food processing industry based in Bhopal. His strategy council has promoted the company and excelled in the way of innovations and finding a suitable market position. So let me invite Dr. Patil here. So please, sir. Huge round of applause for Patil.
Very good morning, everybody. First of all, I would like to thank Dr. Oberoi and the NIFTEM team for giving me this opportunity to share my thoughts with you. Actually, when you look at food processing sector, we say that it is a sunrise sector. But we have been saying this since last 50 years. Sun should have risen by now. What are the reasons for not having that kind of output from food processing industry or food processing sector? The reason is because in the food processing, there are 3 stakeholders mainly. The one is farmer, second one is processor, and third one is the consumer. If we can keep this supply chain smallest, it helps the first fellow as well as the last fellow. But when we look at this chain, instead of these 3 key stakeholders, we have in between many stakeholders, and they are not responsible for anything. In fact, they are there only to make money. So what we have to see that these all three stakeholders should be taken care of. When we see the effect of climate change, it affects everyone, all three stakeholders. But the first stakeholder, who is a farmer, he is taken care of by compensating with the insurances or the government freebies. Okay? Then the consumer, because he has a power to vote, so he dictates many a times the prices. And then the farmer suffers because of that, and he also gets compensated. For example, 80 crore people are getting 5 kg of food grains every month. And so that is how they are getting compensated. But what happens to this processor? He never gets compensated. In fact, for this processor, there are many schemes to start up. You start, you do something. For example, ODOP is there. For example, Prime Minister's that micro enterprises scheme is there. The loans are available, entrepreneurs are enthusiastically going in for that, but some drastic climate change happens. He is the most maximum sufferer because he needs to have the quality raw material at the affordable price to be sustainable. But he never gets that kind of help. So through this platform, I would like to request NIFTEM, Dr. Oberoi, that put up a recommendation that like the farmer is compensated, like the consumer is compensated, our industry should also be compensated in case of this climate change. Because if it is not there, and that is the reason, I believe, that is one of the reasons that why this sun has not risen. And we always call it as a sunrise industry to get people into it, but then we just leave them at their own to struggle. So with this background, I am going to present my presentation. Let us understand the climate change challenges. So climate change poses multifaceted challenges to food processing machinery and also operations. First is the rising temperature. Yesterday we heard Dr. Kulkarni that even rise in temperature by 1 or 2 degrees, how much it affects each crop, right from wheat, cereals to the fruits. And those all challenges, they have to be faced by the processor or by the consumer. And farmer doesn't have any role in that because the climate he cannot control and he tries to grow maximum even under those harsh conditions. But these things happen and the processor suffers. Next is altered precipitation patterns. We see that in Rajasthan, many a times we see lot of rains. Earlier we were thinking that Rajasthan, no rains. But where there should be rains, now there is a desert. We are very worried about Punjab that it is going towards desertification because all the groundwater is being pumped for agriculture and not many rains are there. I was there as a director for 5 years and for 3 years I was just wondering that why it is not raining here. And because I was coming from Maharashtra where the rain is not a problem and here there was no rain and just because of the groundwater they were growing the crops and that was another burden on the nation. Then extreme weather events which disrupts agriculture production, affecting the quality, quantity and availability of raw material at affordable price for the processor. If he doesn't get it at an affordable price and if he doesn't get a quality material, as Dr. Kulkarni was telling yesterday, whatever raw material comes into the factory, the consumers have expectation that end product should be testing the same way as it was earlier. And that is a big challenge and that's what our processors are struggling for. Another thing is that this not only affects quality, availability of the raw material, but many times it takes away our whole factory. Maybe that the winds are so strong or the rain is so strong, the factories are washed out. And I don't know what is the provision from the government which is there for these factories to stand up again. That is why we have to request the government that this is a sector, if you want to make it stronger, then you have to support it really from your heart, not by just lips. Then water scarcity. Water scarcity is the universal problem and water is the foremost in the food processing operations. Because the washing is the first thing which we do for everything. And that one is getting scarce. Then energy fluctuations. That is also there, because if it becomes energy intensive and if grid energy is not available, now only we have started thinking about the solar and the government is giving the incentives for that. But earlier it was not the case. And also the energy is so erratic in villages or the rural level. We always say that we need to have the production catchment processing. That means we should process where we grow. But where we grow, the energy is available only during night time or daytime or few hours, then how the factory could be run? And it cannot be profitable to run the factory or economically even to run the factory on the diesel fuel. To thrive in changing climate, the food processing industry must proactively address the challenges through strategic adaptation measures. So let us see what are those strategic adaptation measures. So, sustainable solution in food processing machinery. To fight the climate change, to mitigate the climate change, energy efficient technology is the first important thing. Variable frequency drives, advanced insulation materials, high efficiency motors, optimize energy usage in equipment such as refrigeration systems, blenders, conveyors. Additionally, heat recovery system, because most of the food processing operations, that heat application is not 100% utilized, and for that matter we should have the heat recovery system. This is the area I think which is being neglected whenever we design our food processing machines or food processing plants. And then further reducing the energy demand, because when you save the heat which is going west, then definitely your energy demand will be lower. Then renewable energy integration, because if you have the rural level food processing industries, then there is a great scope for solar panels, wind turbines, biomass generators, combined with energy storage system. Because every time we should think about the energy storage system. I think this is the point which is being lacked, which is not being taken care of properly. Have the research projects on this. Energy storage, heat recovery, and those things we require more. The Western countries, they may not be requiring it, but even then, the circulation of the heated air, they are still doing it because they have to heat their air in the winter season. And they have studied it so thoroughly, so nicely, that how much of the air circulation rate should be there, and how many times the air should be freshened up, and all those things they have studied, and we have not. And we have just neglected that field. Then next is water conservation technology, because we know that our industry is water intensive, because we require a lot of water for washing. Even the plant washing requires a lot of water. CIP is not, it is really using a lot of water, and this water needs to be conserved. Incorporate water saving technologies such that closed loop system, water recycling, advanced filtration techniques, optimizing water usage and minimizing wastewater generation. So water conservation, it should be the most important thing whenever we think about designing the food processing plant. Then waste reduction and valorization. Yesterday it was talked about by many speakers that the main product is important, but byproduct is 1.5 times more important. And because from there you can extract very valuable ingredients which are required for fitness of our body, and they are not being used nowadays. We are just throwing the waste. Either it is creating problem or either it is going for the low usage like the composting. So waste reduction. For example, design machinery to minimize waste generation, first thing, and maximize the valorization of the byproducts. Innovative technologies such as anaerobic digestion, composting, bioconversion, organic waste into renewable energy, fertilizer, animal feed, explore circular economy models that prioritize resource efficiency and waste reduction throughout the production process. So we have to reduce the waste. We have to reduce the waste, first thing, and if we create the waste, then use it properly. Have value added. And because there is overall whole throughout the world, people are asking for that actually. We are in a very good position in the world because we don't grow the crop you name anywhere in the world. Whereas all developed countries, they have only 5 or 6 crops grown and they don't grow all our fruits and vegetables, which are very healthy and which are a treasure house of all the valuable ingredients which Western world needs as well as we also need. Then smart automation and data analytics. So this is being talked about yesterday, many people talked about it. Advancement in automation and data analytics enables the food processors to optimize their operations in the real time, reducing the energy consumption and improving the process efficiency. Smart sensors, machine learning algorithms, predictive analytics, optimization for opportunities for optimization. Because whenever you have these smart technologies are not that expensive now and not that difficult to adopt. When the farmer can run his pump in the field from home, why can't we look at our factory from sitting at home or traveling abroad anywhere for the conference, and you look at your factory, and that way if there is anything changes in between, important decisions have to be taken by the workers, those who are working there, managers. You are in contact with them, so use the smart automation technologies and data analytics. Then how we adapt the strategies for food processing machinery, this aspect. Those with the sustainable approaches, energy efficient equipment has to be there. That is the first thing which we should be keeping in mind when we design the process plant or any machine. Then optimizing machinery design and operation, maximum energy efficiency, incorporating features such as variable speed drives, heat recovery systems and insulation. Because these are the things which require our attention now. Because we need not refer to the old manuals, and because all industries, not only food, they require these things, and that is why available. Variable speed drive, it was talked upon yesterday. Heat recovery systems, they are there being developed, and insulation upgrades. We want very good insulation now and very affordable cost it is available, and that we should be using. Then climate resilient infrastructure. This infrastructure, why it is important? Because many times we see that when the strong wind flows because of the climate change, the factories they get destroyed, and that is why so design and retrofit processing facilities to withstand extreme weather conditions and temperature fluctuations to enhance. I think why it is moving that fast. Climate resilience and minimize the downtime. Another thing what I have seen in the Western countries, their labs are pilot plants. Their labs and pilot plants are just like our factories. And in that, they have the machines which can be reorganized. So that you don't have to be having many dryers, you don't have to be having many mixers or many grinders, and whenever you want, you just make that pilot plant ready and use that. So that is kind of thing we should be doing. That means when we do that multiple crops should be handled, and multiple machinery could be adjusted one after other, and the pilot plant or the plant could be prepared. I think I'm going to conclusion. My time is up or what? Is it automatic? Okay, I don't know what to say. मेरा हाथ आ रहा है क्या? Climate resilience ये आ रहा था. Then was okay, I got it now. Okay, ये climate resilient infrastructure हो गया? फिर घूम रहा है. Then water saving technologies, remote monitoring and control. That is what just now we discussed. And modular and flexible system. That is what I have given the example of the pilot plants from Cornell or pilot plants at maybe Kansas State University, and there where they have. So they don't have pilot plants like us, because we have grain milling pilot plant, we have dal milling pilot plant, we have another crop pilot plant, and don't do that. Maybe make a flexible design, these things, and the one pilot plant should have all these equipment, and you can, they should be modular, and then flexible processing systems we should have. Then the next one is adapt scalable equipment design. The equipment should be such that, not that every time we buy the new one, but the equipment should be scalable. So then only industry will accept it, and that is how the efficiency will increase. Then sustainable material and practices. Utilize recyclable material, biodegradable material, eco-friendly material for equipment construction, and that will minimize waste generation. So next is how to mitigate the climate change effect. So this is the list. Storage of raw material, first thing we require. Cleaning and sorting has to be done. Peeling and trimming has to be done. Cutting and slicing has to be done. Then next is blanching, then drying, canning and bottling, freezing, juicing and extraction and fermentation and quality control and packaging. These are the unit operations which face the effect of climate change nowadays. And we have to take care of that. And I am not going to cover everything, but I have taken 3 important ones from them and how we can mitigate the climate change effect. So, the modern storage methods to mitigate the climate change. We should be using controlled atmosphere storage. We should be using modified atmosphere packaging. We should be using vacuum cooling, hydro cooling and immersion cooling. These are the new technologies which are available now. And the solar powered cold storages are available. Then thermal energy storage system we should have along with the solar powered solar energy extraction or solar powered cold storages. They should have thermal energy storage for excess energy if they generate, and remote monitoring and control system. This is required for mitigating the climate change effect on the storage conditions or the storage operations. And by leveraging these modern storage technologies and practices, the food industry can contribute to climate change mitigation effects while ensuring the efficient and sustainable storage of fruits and vegetables. Next is drying system to mitigate the climate change. Drying is one of the important operations in the food processing, and we should be using the new or modern technologies which are there, which are energy efficient, like heat pump drying, like solar drying, microwave drying. And I'm seeing that now there are many farmers are adopting to solar drying, and there is a company in Indore. Mr. Lahija is the owner of that company. He gives the dryers to the farmers. Farmers dry the material, he collects it, he reprocesses it to the same washer content and then exports it abroad. And even in India, now the dry processed products are very much liked by the next generation processing industries, like the end product processing industries, the tertiary processing industries. Then vacuum freeze drying, fluidized bed drying, spray drying and superheated drying. By adopting these modern drying technologies, the food industry can reduce energy consumption. It can reduce the greenhouse gas emissions and environmental impact while producing high quality dried fruits and vegetables for consumers. Next important operation is modern juicing and extraction method to mitigate the climate change. Because what are those processes which we should be adopting now? If someone client comes to you that you design a juicing plant for me, then you should go for the modern equipment which are now available, which are energy efficient, and that is how we can mitigate the climate change effect, because they are faster for adapting to different qualities of the raw materials and under different environmental conditions also, like cold press juicing, high pressure processing, pulse electric field extraction, ultrasound assisted extraction, enzyme assisted extraction, membrane filtration and supercritical fluid extraction. All these technologies individually or in combination should be utilized so that our climate change effect is mitigated or reduced. So let us conclude now what I have spoken for this last 10-15 slides. Adapting food processing machinery to changing climate is essential, definitely, ensuring the resilience and sustainability of the global food supply chain. Incorporating energy efficient technologies, renewable energy integration, water conservation measures, waste reduction strategies and smart automation, food processors can mitigate the impact of climate change while enhancing the operational efficiency and profitability. Then collaboration between industry stakeholders, policymakers and technology innovators is essential to drive the adoption of sustainable solutions and environment-friendly food processing sector. Proactive adoption and innovation in food processing machinery will be critical to ensuring a sustainable future for food production and consumption worldwide. So whenever we are going for this modern technology, we have to ask the government that there should be extensive subsidies or incentives for the processors to buy those new equipment rather than the old ones which are available in the market. So this is one of the stakeholders who is the processor. He should get the support from the government, and I think this platform should make a recommendation for that. With this, I thank you very much for giving me this opportunity.
So I think huge round of applause for R.T. Patil sir. Thank you sir, thank you for sharing the valuable insights of the aspect. I think you have touched upon all the challenges regarding the processing, regarding the machinery design, regarding the challenges which we face, and then what are the solutions. I think there is a lot of brainstorming that we need to do that with perspective of India, what is required at farm level, at the startup level, at the farmer level, and I think very rightly said that the government should also incentivize the process. I think this recommendation, I think there's a lot of things that we can do on this particular aspect, and hopefully this has led to another voice where industry can be benefited, and the new entrepreneurs who are planning to enter this sector, I think they can be benefited. Thank you sir, thank you for sharing. So next speaker is Dr. C. Anantharamakrishnan, Director General, Director CSIR, National Institute of Interdisciplinary Science and Technology. He is an active researcher with more than 2 decades of experience in research and administration. His research has endeavored well documented in the form of 213 impact factor publications, with an average impact factor of 5.7, 3 international patents, 9 Indian patents, 1 commercialized technology, 8 patents applied for registration. He is also the author and editor of 15 books, 112 book chapters, and covered over a large number of publications. He has supervised 17 theses and more than 50 bachelor's and master's theses. I think he is the person who we are willing to hear. So I think a huge round of applause.
Thank you so much. First of all, I would like to thank Dr. Oberoi inviting me for today's this podium. NIFTEM Kundli is not new to me. I was part of the board for more than 6 years of NIFTEM Kundli, and the way in which is moving on the NIFTEM Kundli, contributing to the food science and technology, food processing sector is very commendable. Along with the NIFTEM Tanjavur, I was the director of NIFTEM Tanjavur 6 years. Now both the institutes have come to the stage. India's food processing totally depending on these 2 institutions. Earlier it was not in the case. Very few institutions is supporting to ministry. Now these two institutions is a double engine to move the Ministry of Food Processing industry, in particular, in general, India's food processing sector. Today I am going to talk entirely different than what Patil sir has mentioned about it, food processing and climate change. People often say, what is that climate change relevant to the food processing sector? Can you believe 26% of greenhouse emissions is contributed by the food and food processing sector? 26%. We are talking about vehicles, we are talking about solar, all these things. But often we neglected what is that impact of food processing sector. Every day, if rain comes, today southern India full of rain, now here hot, climate has changed. That's what we are telling. But climate has not changed. We have changed the climate. Climate is exactly the same. We are continuously dumping, changing our air. If you look at that 1970 to 79 and 2010 to 90, floods 3 times higher, forest fire 4 times higher, storm 3 times higher. Why it is continuously happening? Each and every corner of the earth is happening this is. If you look at our surface temperature of the earth, the year of 1865 to now, you see that how the temperature is rising one by one. When the industrial revolution starts at 1990, the temperature started picking up. That our cutoff point is ideally 1.5, not 2. We fixed it 2, but we should not allow to go beyond 2. If you crosses 2, what will happen? Antarctica start melts. Chennai will go off. Calcutta will go, Bombay will go. This is the what we are going to face future. We need to think very, very carefully. We are thinking once climate change is not only vehicle emission, we are putting every year vehicle norms and all emissions. Look at what is that energy usage. India is third largest energy usage, including this hub. 30% of the energy usage comes from the ACs and making the cooling of this type of hall and the house, everywhere. And in turn, if you look at, India is fourth largest emission of carbon dioxide. Per capita, it's almost 1.9. Is it allowed to go like this? Once our population is continuously in rise, then see that this both the figure, right and left, this is the main cause of the whole impact of greenhouse gases. But not only is the good picture to show here, 30%, 38% oil dependent gas, and see we are telling a 20% bioethanol can be added. Is it possible? No, we already, maybe ambitious target, we are already 10%. What is the cost of bioethanol production now? Per liter goes beyond 100 rupees. The enzymes what you wanted to produce the bioethanol comes from only one company. Even this many organizations, research institutions are there, we are not able to produce the enzymes to produce the bioethanol conversion. See that what is the demand, highest peak demand has happened in 2020, 2050, what is the demand, we are not going to make it, whatever the fossil fuels available in the earth. This is the one side of the story. You come to our own story of food processing, if you see the food processing value chain, Patil sir has mentioned about it, it comes from the production, mainly the field, agriculture, small and medium farmers, producers, everything, then primary processing, grading and sorting, washing, all these things happen in the primary processing, then goes for the value addition. We are making different value added products. That's what our job, we are doing it, continuously we are doing it. Without food processing, you can't expand the shelf life of any of the agri commodities. Then goes for the packaging, then marketing and export. This is all this point of the value chain. Each and every place carbon footprint is there. You look at the first 3 points. The huge amount of the energy input goes, same time huge amount of the waste. Is the solid waste, liquid waste, grading, washing, everywhere liquid waste is coming and the solid waste. Any of the fruits and vegetable processing, if you go, 20% is wastage is coming. Then carbon dioxide emission is happening in 3. One culprit often we forgetting is the packaging. That is the one today I am going to speak about it. We are often neglecting, but that is the important area. Food processor we are using. Any processed food has to be packaged. The marketing and export what you are putting here, sir. 2 is the carbon footprint. The transport of the material has to go which way you want it to move, and the weight, whatever you are adding, canning, the weight increases. Glass weight increases. The carbon footprint continuously increasing. The selection of the material, selection of the marketing and export is the key element for carbon footprint. Yes, India is growing, consumers want a different type of thing. 100 years back we have taken food for the energy, 50 years back we have taken food for the nutrition. Now what for we are taking? We wanted to enjoy taking the food. We wanted to get a pleasure of taking the food. You see that weekends we are going to restaurant. It was not happened 10 years or 20 years back. Every weekends families are going to the restaurant, taking the food, enjoy the food. That's what. Food is become the part of entertainment and happy family, everything, whatever you call it. Now customers want customization, personalized nutrition, different product range, ethical food choice. What is that? Recent studies demonstrated in the US, 40% of the population wanted to buy the product, the company manufacture, ethically manufacture, no child labor, fair trade, they use the biopolymers or the environmentally suitable packaging material they wanted to buy. That's what you know that one of the famous mobile phone, they told we are not going to produce we are not going to give the charger. Because they told we don't want to more material into the gas. So we love it. So that's what now the food industry also think how to manufacture like that. And the brand, they wanted to create a brand around that. You see the coffee, 20 rupees coffee, you will get it in the local shop, you go to another good shop, you will get the 100 rupees, you will get the coffee at 500 rupees. Same coffee bean, same extraction, everything is same. Only thing, the way in which they deliver to you. Then they create a brand around the food. It was not the case earlier, now it has come into the brand also play the role. In that scenario, Indian food industry continuously growing. Right now it's a $268 billion business right now, 2024. And it's predicted next year it's going to be 535 billion. Definitely you know that after election results what is happening in the food industry, Genius are sitting in front of me, they know that last year 52 billion we are exported. 35% increase in ready to cook product. It's continuously the rise. If increasing the food industry such a fast and rapid phase, definitely that will impact on carbon dioxide emission. The total carbon dioxide emission is from the food system is 13.7 gigatons. That is equivalent to the total 26%. We are contributing 26% of the carbon dioxide emission in the global. So who will going to address this one? We wanted to achieve 2050 net zero. Is it possible to achieve? Government of India told 2070 is our target to achieve the net zero. Where we have put up the plan to reduce this 26% of the carbon dioxide emission in the food system. If you look at the food system, greenhouse gas emission takes place in the food is 13%, non-food is going on 38%. The land usage is 50%, water usage is 70%. We are taking most of the resources in the earth for the development of the product and the processed food or the convenience food, whatever it is. So my suggestion is we wanted to look into the 3 P's for the food processing sustainability in the future. One is the production, second one is the processing, third one is the packaging. Production, yes, this is the main culprit. If you like it or not, ICR people are there, they know that it is the important, and we need to see that how best we can have an alternative to do that. Beef, so animal processing, animal agriculture, fish, all these things contributed more. You see that highest amount from the beef, chicken and the other processing, it comes continuously there because the amount of methane is released from the animal agriculture, animal source food. Then other source, either rice or wheat, water intensive or the energy input is going to the field to convert package of the rice. How much energy input is going, how much calories you are getting. That is the key element. We need a calories, this much amount, that much amount of the energy input is nothing is balancing. I will give a simple example. The best conversion is the chicken. You give the 9 calories of the feed of the greens, vegetable, whatever you give the feed. What is the amount of calorie outcome is coming from the chicken is only 1 calorie. This is the best one. If you see that beef, 40 calories in, you are getting only 1 calories out from the animal. Over and above, land, water, all these things is going in. What is the alternative in front of us? We need a protein for our human being to live. Further, this is the best alternative or any other alternative with us. That's what one should think. The best alternative is alternative protein from other sources. We have done, you can take the soya or other proteins, you take the extraction of the protein, you make the meat like structure. There's a meat analogs, we can do it from 3D to printed. NIFTEM Kundli, we have done this work. Even NIST, we have made the meat analogs using that. Even we reached at 28% of the protein in the what is that condition, and we can get the same type of taste and whatever you feel it about, everything it can be given from the meat analogs. This is the one alternative. I am not going for the detail because today I am not going to talk about alternatives. Look at the processing. Parties are mentioned about auto processing. I give only one example of carbonated beverages. If you take it from the production machinery, 5.6 gram of carbon dioxide per liter of the carbonated juice. Then 54 gram the sweetener is produced. Packaging is produced 58 gram of carbon dioxide per liter of the carbonated juice. This is the line. If you take it, you calculate each and every machinery is what is the footprint of the carbon. This is the what is coming. So where we have to look into that. One is that the feed, second one is the packaging. At least we will take it next 10 years, we address these 2 things. Can we reduce some extent? Then we will move on to one by one. That is the what we need to think how best we can go. Look at here, production versus the processing versus the packaging. The first portion is the beverages, grains, dairy. The first line is the production, second one is the processing, third one is the packaging. These 3 components we need to look into that. So production and the processing, already yesterday maybe would have been discussed about the production of the different agricultural crops, how much reduces or increases the carbon footprint, and just now sir has mentioned about the processing the machinery. Now I am going to talk about the packaging, which contributes 4.6% of total carbon dioxide emissions among all the food systems. The processing is 3.5%, production is 39%. So I will focus on now packaging. We'll switch over to the packaging. How we can reduce the packaging to make net zero future. Our target is we can keep it at 2050, not 2070. If you look at every minute in India, 15,000 multi-layer packets are purchased and dumped. Whatever is the Tetra Pak, whatever it is, the climate is, it has to be recycled. But India, we are not able to recycle, that's what it is the problem. If the layers and the composites are involved, aluminum layers are there, you can't recycle that easily. What one should think about it. Right now, per person is using is almost 8.6 kg per person. We are using the packaging consumption. Take it on chocolate. You eat through a paper. Where that chocolate paper is moving, can you think about life cycle of that paper? You can't even imagine. For a day you are taking 2 chocolates, per month 10 chocolates. You think about, just you put it in your mouth, 5 minutes you enjoy, finished it. But the life cycle of that paper, where it goes, where it ends, that is the what important. And the plastics is comes from the rivers to the sea. It moves each and every place, these plastics. But market is tremendously increasing, and US market 1.14 trillion, it is increased to 1.38 trillion, predicted 2029, and India's market is booming market, and the plastics and all the packaging is 84, it's predicted 142 billion in the future. Mainly the paper, 33%, then flexible plastics 25%, rigid plastics 18%, then metal, glass and other things. What it contributes? Look at here, 9% of the plastics only recycled. The paper, globally 17% are waste. But one thing you should understand, paper is not come directly. It comes converting the tree. You are cutting the tree. That means 50% less carbon dioxide you are releasing. People are thinking, I use the paper, I am the responsible. No, you are already stopped absorbing the carbon dioxide to the tree. Then how much energy is going inside? And the 20% of the waste is from the packaging industry. The simple example, what is we are predicting is 1.34 gigatons of the carbon dioxide emission only from the packaging industry. That is equivalent to the 300 number of 500 megawatt coal power plant of emission. Can you imagine? India is moving at this fast, 535 billion size of their food market, 35% increase in ready to cook product. That means this is the what finally we are going to enter. So we need to address this is the problem. Right time, this type of conference has been arranged to mitigate this one. That is the important. It's a responsibility of NIFTEMs, both the NIFTEM Tanjavur as well as NIFTEM Kundli has to put up a special program how to do that. Otherwise, it's not going to happen in soon. See the 380 million tons of the plastics has been produced. We will look at only plastics. Out of which only 50% is recycled. That means 190 million tons is dumped every year on Earth. Every year adding. You see that cumulative how much is going to be dumped on our Earth. And 1 million sea animals are died because they are eating the plastic as the food. And we are taking 18 kg of the plastics and we are able to recycle only 86% of that. Then we can split into this plastic into microplastic, nanoplastic. You know the size, I am not going to further. Right now, look at the sea. 1 is to 3. 1 ton of the plastic is the 3 ton of the sea. Fish is there in our sea. 2050, it is going to be 1:1. Can we afford to do that one? Then you can't eat fish. Now also today you are taking the seafood, you are taking the plastic. No other way. So this is the what continuously is happening. You look at that. Who has given permission to spoil the sea? Who has given permission us to do dumping all this matrix? Our soil structure is changed, our sea structure is changed, everything is changing. But culprit is, right or wrong, 40% culprit comes from the food industry of you and me. The microplastics, that less than 5 mm to 1 micron size is particle is called as a microplastic. Right now per year you are taking 900 microplastics you are digesting. Can you believe every week you are taking 1 credit card size of the microplastic you and me we are taking? Yes, this is the data is true. Only thing where we are saved is, it is not absorbed in our body. That is the what we saved. It comes out. But think about particle sizes goes less than 75 nanometers or 800 nanometers is crossed that blood-brain barrier, it goes to your bloodstream. Same microplastic, put up the cancer in our India, microplastic, bisphenol is coming, exactly map. You put the cancer rise and the microplastic absorption, exactly interlinked. Till date, we are thinking about plastic dumping in the earth or throwing that, is only affected by the climate change. No, it is affecting your health. That's what we need to think. How it is coming to us is the food chain. If you are not stopping there, we are going to face huge problem. Bombay, 500 microplastics are present in the drinking water of Mumbai. Recent study that done by the ICR group. That recent study in the Tuticorin, all the water, river water has 138 microplastics are present into that. Now, Mr. Wonder, we have taken the studies. We wanted to see that how it is affecting the absorption of the nutrient when it goes for the systemic circulations. It is crossing the blood-brain barrier. How it is changing the villi and microvilli in our systemic circulation. That's what we have taken the study. The value, what you look at, the plastics value, you consider only 14% are recycled. That means remaining value of this product are wasted. That is almost 80 to 120 billion amount of worth of the value we are losing. And FICCI has reported 133 billion worth of the material lost by 2030. We don't have the data right now with the Central Pollution Control Board. We have the data from the 2015 to 20. You see that 15,89,000 tons per annum plastic waste has produced. Now it's the 34, already doubled. Another 5 years time, 25, definitely will have been doubled. This is what going to increase. This all plastics goes in everywhere, including coming to your body. What is the technological gap as a NIFTEM Kundli or Tanjavur or NIST can do? One is that shorting of the polymer waste is difficult in not only India, everywhere. We are talking about PLA, PHP, all the things for biopolymer alternative. Where are these? How we can recycle? We put a lot of effort to create a biopolymer. Can we recycle it? This biopolymer goes to the polyethylene, you can't segregate. Then what is the method to do that? And degradation method, can we accelerate the degradation? That is the one. Microplastics, mitigations, how it is travels, which industry is releasing this microplastic into the river, and the fossil fuel, all these things. Yes, I said paper is not a good alternative. 15 billion trees are cut down every year. 4 times higher energy needed than the pot plastics. 70% more pollution it creates. 50 times higher water needed. When you wanted to make a paper, you need to have a wood or waste paper, then pulping, chlorine, bleaching, then you have to make the dryer, roller dryer, all of these, then you get the paper. This is the what happening. So thinking about paper is not a good alternative. Even we are not doing the good recycling. India has done very well. 2011 we have done 29%, now it increased to 43%. But this has to go more than 70% another 5 years time. That's what we need to look how best we can do. Can we go for the glasses alternative? Look at the production of the glass. We are making the 36 million tons per year. The amount of the carbon dioxide released to making the glass is quite very high. Okay, that is the one side of the story. Second side is if you wanted to recycle, it releases 2.2 million tons of the CO2. This is the what it is. Glass also is not an alternative. Then what is the other alternative? Can, right? But I come to that story later, and if you look at the metal and glass, it's a fragile, more carbon footprint, recycling challenges and mitigation is always high. This is the what can story. If you look at the per ton of the production of the can and PET bottle, the CO2 produced the PET bottle is 2.3, and look at can, it produces CO2 is 12.22. So you see the can is automatic. So we are in the situation, we are in the scenario. Nothing is available in front of us when we are talking about sustainable packaging. So what the consumers want, what the industry want, where is the technological input is needed. That I leave it to all the students and technologists can think about it. We need to come up with a solution. Not only that, we don't have the solution for testing. Accelerated condition, at-home condition, how much, which are the method can be used to test the biopolymer. Monitoring system. We don't have the life cycle analysis of this material, how it goes, the blockchain. You see, what plastic has produced, the raft, where it ends. Any industry has that data. If the data is there, then we can know that the whole chain of the actions, then we can stop which point we need to stop. The recent status is very clear. Consumers, you and me wanted to go for the sustainable packaging. Yes, we wanted. 57% wanted to go for sustainable packaging. In Indian scenario, the recent data. Even 71% wanted to pay higher amount of the money to buy that type of product. Yes, market is growing 5.46 million tons. Right now, it's going to be 8.22. tons in the future. Yes, that is the quite lot increasing, and the global market also increasing 7.67%. It is the 292 billion is going to be a 423 billion type of the market share in the sustainable packaging. What we have to do? Yes, we have to rethink. You see the two scenarios given here. Plastic market is 22 billion, but the impact of the plastic waste, either municipality to the corporation to the large industries, segregation, collection and recycling, that put money worth of 139 billion. So here only we have to think very, very closely. 535 billion business you wanted to make in the food processing sector, but the government has to spend another 100 billion to manage that waste. Is it a correct way of approach as the food industry? I leave it to you. Think about it. We need to put a lot of effort. That's what I wanted to say. Thanks to Uberai sir to put up the such type of topic. Always we are talking about food industry is good, good, good. We have to also think about and say what is the problem we are facing, what this industry is facing. What is the solution for that? One is the good manufacturing practice. Yes, true that. Adapting the less energy, saving emission, reduction in energy input in every stage of the processing. Small unit operation, you need to see that how best you can reduce the energy input. And sustainable packaging solution, till now we don't have the clear biopolymer in front of us. We have done some biopolymers using the PHP and PLA along with the cotton. Printability is the problem. And if you blow it to extrusion, you can't get that temperature, you can't make it. The strength, you can go for the nanocomposites. If you put the nanocomposite, leaching is happening on that. How best you can put the nanocomposite? So this problem we need to address. If we are not addressing, who is going to address? The storage and distribution system has to be segregated. This centralized system has to be avoided. If you make it a centralized system, you are increasing the more carbon footprint. So decentralized, you make it as close as units are very close to the metros, then distribution system can be reduced, then carbon footprint can be reduced. After I took over as the director of CSIR NIST, we proposed that sustainable packaging mission. Already this mission is on. Almost 17 CSIR labs joined together. We are working on it. CSIR NIST is taking, I am the mission director for this whole mission program. We wanted to bring sustainable packaging solution within another 3 years' time. Can we have alternative to Tetra Pak? Yes, that's what we are trying to do. Can we make the bottles, instead of glass bottle, can be biopolymer bottles? How to recycle it? More than institutions, this 17 institutions, we have 30 industries joined hand with us this mission. We wanted to work very closely with the industry to bring out lot of solutions what right now packaging industry facing in our nation, including centralized testing center at CSIR NIST for the biodegradable testing. All the testing can be done in CSIR NIST. See, this act is not belongs to you and me. It's a future generation too. If you are not saving this act, tomorrow what we are talking about, dinosaurs was there sometime. Tomorrow somebody will tell about humans are lived this act. We can't allow it to happen like that. The responsibility with everybody. The future depends on what we do present. Make a good food, makes you happy, keeps you healthy, saves our planet. Thank you so much for coming.
Thank you, sir. Thank you for sharing the insight. I think summarizing this particular presentation is very difficult, that what aspect has been presented, what is the other dimensions we are looking into the food processing. And yes, if I am consuming 8.6 kg of plastics as a consumer, I think that we need to really think about that, in which direction we are going. So really a thing that we need to discuss and we need to implement, rather every minute data for the materials which are being packed and that it is dumped. I think that is again an eye opener for all of us. This is not the, I think this is not the end of the session, or this is the end of the presentation. I think there is a lot of thought-provoking idea that might be going into the people sitting over here and the young generation which are looking forward in this direction to give the solution to this. If not plastic, is it paper, is it glass bottle or a metal container? I think again we need to think about it. So looking only from the aspect of carbon footprints, but also from the aspect of our safety and then for the future of the nation. So thank you, sir, and all the best for your mission. I think this is a initiative which you have taken. I think all the wishes from our both the NIFTEM support will be there, sir. I think a huge round of applause for Ramesh, sir. The technical session 4 come to the end for here. So thank you, sir. Thank you for joining us over here. And good morning, sir. So I think there are a lot of ideas and lot of thoughts which are going around over here. But now there are a lot of challenges we discussed. But what is the solution? Solution is the collaboration between the industry and academia, how we can go ahead and what industries actually need. I think that perspective is very important once we are finding the solution, like in which direction we should proceed. So now the technical session 4th is followed by the panel discussion. So I am privileged to invite Dr. C.R. Mehta, who will be the moderator for this particular session. So huge round of applause for C.R. Mehta. Dr. C.R. Mehta is the director at Central Institute of Agriculture Engineering, Bhopal. He is having specialization in farm machinery, power mechanics, economics, conservation, agriculture, instrumentation. His R&D achievements include optimization of seat design and tractor workplaces, layout, control of noise, vibration and decision support system for farm machinery management. Biomass-based decentralized power generation system. The findings of tractor workplace layout has already been adopted by the 2 leading tractor manufacturers through its consultancy projects. So I think huge round of applause for the moderator over here for this session. So now,
So, good morning everyone. So, today we had 2 keynote speaker talks. Both were very important, particularly to address the climate change, how food processing industry is affecting it, and how it can be addressed also. So, I may not go into details, but as you know, that in food system, there are different processes. It has already been mentioned by our previous speaker also. One is the production, another is the processing, then transport, then packaging is also there, then distribution, then preparation, then consumption, and sometimes food waste is there that has also to be disposed of. So all these value chain in food system contribute to greenhouse gas emissions. Mitigate it, that has already been mentioned by both these speakers, particularly Dr. Patel had talked about how we can use the energy efficient electricity, how we can minimize the water use in food processing sector, and Dr. Ramakrishnan has already mentioned about the importance of packaging in greenhouse gas emission and how it can be reduced, and he had even open up that what may be the options to address that issue. So in this panel discussion, we have 3 panelists, and these 3 panelists, 2 are from the industry side and 1 from ICR side. So panelists are Mr. Ranit Rana, who is Associate Vice President, Sales and Distribution, Jindal Stainless Steel Limited. So he graduated in Meteorological Engineering from Indian Institute of Engineering, Science and Technology, West Bengal. And he also obtained a postgraduate diploma in management from SP Jain Institute of Management and Research, Mumbai. He had worked with Tata Steel for more than 10 years. Then he worked with Usha Martin for around 3 years. And for last 12 years, he is working with the Jindal Stainless Steel Limited as a Vice President in Sales and Distribution. So we welcome him to this panel discussion session. And one of the good and different thing what I observed in his biodata that he has represented Bengal in Vijay Merchant Trophy National Cricket Tournament. But nowadays everyone may be watching the IPL also. So he one of the good cricketer. I invite him on the dais. Another panelist is as I am informed that time is short for this session. So I will be briefing about the other two panelists also. So next is Mr. Shashidhar Subramanian. He is Head Corporate Technology, Bohlar Group. So he is working with this company since 2014. He is having Bachelor in Engineering in from Bangalore, Master in Applied Mechanics from Indian Institute of Technology, Madras, and then also he has completed Master degree from NIT Ahmedabad, and particularly this industry is engaged in energy efficient food processing technology. I invite him on the dais. And one of the important our stakeholder, that is Indian Council of Agriculture, he is Dr. K. Narsaya. He is Assistant Director General Process Engineering, Indian Council of Agriculture Research. He is Assistant Director General from 2022, and before that he was scientist at NDRI Karnal for around 8 years, 8 months. Then he was senior scientist at CIFET Ludhiana, then principal scientist. Also he has worked on number of projects. In addition to that, he has also 14 patents to his credit. So I invite him also on the dais. So now we start this panel discussion, and in that we will have a few questions as well as what their industry or their organization is doing. Particularly first, my question is to Mr. Ranit Rana, who is Associate Vice President in the Stainless Steel, and this company is mainly engaged in production of steel. So I request him to give some feedback that what makes stainless steel a suitable material for construction of food processing machinery, and how his organization is supporting innovation in stainless steel manufacturing, particularly to address the climate change. Dr. Rana.
Am I audible? Yeah. Good morning, everybody, and thank you so much, Dr. Mehta. So I represent Jindal Stainless Limited, and we are completely into stainless steel. Stainless steel, as you know, it's a 100% recyclable material, and therefore it's a completely green steel. So it is one of the most sustainable options which is available today, primarily for the food segment. And when we look at stainless steel and the food industry, they are intermittently, they are quite interlinked, in the sense that if you look at globally, almost 30% of stainless steel consumption happens in the food industry. And if you compare that with what's happening in India, it's almost about 60%. So food industry is one of the most critical segments for us. And when answering what Dr. Mehta has asked, that what Jindal Stainless is doing as far as sustainability is concerned, so we have planned or we have undertaken projects which amount to a value of about 700 crores. We have invested towards sustainability projects. We are the first stainless steel plant, most probably in the world, to have a green hydrogen plant. We've also installed solar panels, both floating as well as rooftop. We have renewable power also. In fact, we intend to meet all our power requirements through renewable energy. So plus of course, there are other initiatives like switching over from road to rail, waste heat recovery, increasing the recycling content in the manufacture of stainless steel. So we have undertaken various initiatives, sustainability initiatives, and which in a sense would help us become a net zero company by 2050. That's our target, and we want to be 50% of that by 2035. So this is in terms of sustainability aspects. Now coming to the point that how stainless steel is a suitable material, I was so amazed by Dr. Ananda Radhakrishnan's presentation. In fact, it's such a wonderful presentation. And when you were showing the slides that what are the materials which we should not use, like he talked about plastics, he talked about glass, he talked about paper because we think that paper is an alternate for plastic. He talked about aluminium, and I was just worried that he should not be talking about stainless steel, which he fortunately did not. So stainless steel, is one of the most sustainable options. In fact, as he had rightly pointed out, when you are looking at aluminium, it produces about, if you look at the emissions, carbon dioxide emissions, it's about 12 tons of carbon dioxide equivalent per ton of aluminium produced. Whereas in terms of stainless steel, that figure is about 2.11. So it's almost 5 times lower. Why stainless steel is, considered to be a food grade material? Of course, because it is highly corrosion resistant. And while I was coming to this venue, I was just going through some of the figures. So I read that, across the world, if you look at the corrosion problems, so corrosion accounts for almost, so $2 billion is wasted or expended on account of corrosion in the food industry. And if you look at India, the total annual loss because of corrosion is $110 billion, out of which 16 to 17% is attributed to agriculture. So this is one of the major menaces. And stainless steel, because of its inherent characteristic called self-passivation. So what is self-passivation? Self-passivation is, the corrosion resistance property of stainless steel is given because of the formation of a layer called chromium oxide. Now, if you look at stainless steel, the composition of stainless steel like 304, and there are various other food grade stainless steel. The chromium is about 16 to 18%. So as soon as this layer is broken, then immediately the chromium from the metal, it reacts with oxygen to form chromium oxide. And that is the underlying secret of the lasting, the corrosion resistance properties of stainless steel. And why is it such a long-lasting material? If you look at galvanized material, it has a zinc coating on top of the carbon substrate, of the steel substrate, and therefore, during forming or during washing, this zinc layer, it gets peeled off from certain areas. So this is called flaking, and from those regions where the zinc layer gets peeled off, the corrosion starts. So that is the major difference between stainless steel and other material. So this is why the stainless steel is so highly corrosion resistant. So that's one of the major reasons why stainless steel should be used, or stainless steel is designated as a food grade material. The others are, it's also able to withstand very high temperatures. So if you look at 304 or 316, which are really used as food grade material, they can withstand temperatures as high as 1000 degrees centigrade. So plus, if you look at the antibacterial properties of stainless steel, that's one of the most optimum material because it doesn't enable the growth of bacteria. So plus, it is easily cleanable. In fact, here I give an example of, if you have seen the Chrysler's building, the Chrysler's building was built in 1930s. So over the last 100 years, it just needed to be cleaned thrice, and that also with soap and water. Generally in my presentation I have that photograph. But what I mean to say is that, and the grade which they have used is a variant of 304. It's 302 grade of stainless steel. So what I want to say that is stainless steel is easily cleanable. I know the maintenance cost is much lower, and therefore because of its corrosion resistance properties, because of its resistance to high temperature, because of its easy cleanability and durability, so these are designated as the most suitable material for the food industry.
Thank you, Ranaji, for briefing about the role of stainless steel in food processing machinery, as well as informing us about the green hydrogen plant established by the company. So congratulate you. So now I move to next panelist, Mr. Subramanian. He is from Bhola Group. So my question is that how your organization is supporting innovation and transformation in food processing sector to fight the climate change? And how do food processing machinery contribute to greenhouse gas emission and climate change? It has already been talked, but I may like to know, what this group may like to know particularly, what is your role of your company?
Okay. Thank you for the opportunity to represent the Bureau Group in this August gathering. I think the topic is very important, and I would like to especially thank the previous speaker for really laying down the context very well and making our job easier. We don't have to re-emphasize the need for working on the sustainability aspects related to food processing. So, Bureau Group touches about the food that's consumed by about 2 billion people every day, either in the grain space or in the food space. With that being the responsibility, it's very important to look at our impact on the carbon footprint, on the greenhouse gas emissions, and these important topics. Now, if you look at the way these metrics are evaluated, it's standard across. You have scope 1, scope 2, and scope 3 emissions. Scope 1 is the direct emissions, what you do internally. Scope 2 is you are responsible, but you purchase it from other parties. The emissions are related to that. And scope 3, you have got upstream and downstream, what you purchase and what you sell, the use of your goods. If you look at Bueller as a company, our carbon dioxide equivalent emissions of our scope 1 purchases is about 770 kilotons of carbon dioxide equivalent. Scope 2, what we generate, the emissions of carbon dioxide because of internal operations is about 70 kilotons of carbon dioxide equivalent. So that's about 1/10 lesser. The big elephant in the room is the downstream use of the equipments that we make. The equipments that when they go into the industry and when they get used, this number shoots up to 42 million tons of carbon dioxide equivalent. So it's an order of magnitude 3 times bigger, 1000 into 1000 is what it is. So this should be the key focus of a company like Bueller and people who make the food processing machines, because the biggest lever of impact is here when it's ultimately getting used in the industry. For the internal operations, there are many measures that we have taken. We have made a public commitment to reduce our greenhouse gas emissions by 60% by the year 2020. And we have taken many different measures. For the shortage of time, I will not get into these details. The conversion of many of our sites into solar, photovoltaic, and the use of biomass as an energy source for our thermal needs. There are many examples, but I won't touch upon this. I would like to quote a few examples of the solutions that are actually contributing to the reduction of 42 million tons of CO2 equivalent. You take the examples, and I can quote many. So this has been being run as a strategic program within Bueller. There are 70 technologies that are evaluated for their impact on climate change and carbon dioxide emissions across 16 different business units. Some examples that could be relevant for this audience are Sortex. We have all, I think most of us here are aware of the sorting technology, right? What's the biggest challenge here? You want to separate out the good grains from the bad grains, but in the process of doing that, you end up ejecting a lot of good grains as well, because you don't want your food to be contaminated with bad grains. And this, what is the impact of this? The carbon dioxide equivalent of this is about 700 kgs. And out of that, about 600 kgs comes because of the raw material. It comes from the production itself. The milling contributes to about 50 kgs of carbon dioxide equivalent. So what does this actually mean? You have to make your machineries and processing lines so efficient that you do not waste a single grain of material that's coming into your plant. That's the biggest lever of influence that a company like Dural has to make the machineries as efficient as possible. Because every grain that is saved, you're not saving in the 50 kg carbon dioxide equivalent, but it's going into the 2/3 that's actually contributing finally. So, a proper sorting technology, a good sorter from a bad sorter, would actually reduce about 50% of the good grains from being produced. Now, you do the math because it's contributing to the first column of production. There are many other examples. For example, if you integrate a drive system into a roller mill, you could reduce your energy by about 10%, which would directly contribute to about 200 tons of carbon dioxide equivalent. I'm talking about a 500 ton per day, 600 ton per day plant. Now, you have to juxtapose this information with the 13.7 gigatons of carbon dioxide emission that's totally coming out. And what's the global production would be today? About 770 million tons, right? So you have about 10,000 plants that are catering to the processing of wheat, and you have the multiplication factor already. So this is the space that Euler operates in. We are trying to optimize our processing equipments, not just to reduce the energy, reduce the water, because that's direct contribution. But the biggest impact we can have is in increasing the yield of the food processing factors. So I would like to stop with this and maybe elaborate on follow-up questions.
Thank you, Mr. Subramanian, for speaking about the role of renewable energy, particularly in enhancing the energy use efficiency as well as reduction of greenhouse gas emission. And you have also mentioned that even if we save the grain also, that will also help us in reduction of greenhouse gas emission. So now we move to the next panelist, he is Dr. K. Narsaria, he is heading Indian Council of Agriculture Research. So my question is mainly related to that how R&D institutions can play a pivotal role in development of energy efficient processing machinery, because there are a number of ICR institutes under which are engaged in conducting research and development in the field of development of agro-processing machinery, including our institute located at Bhopal.
Thank you.
He may also bring about his knowledge. He earlier worked at Sikhet Ludhiana and he was also involved in development of number of machinery. So in that also he can bring that how extreme weather events like flood, etc. can, what kind of technology can help in addressing such issues to save the food grain.
Thank you, Dr. Mehta, and thank organizers and Dr. Varai, Director NIFTEM, for choosing the timely and relevant topic, as well as inviting us to share our views. Especially R&D institutions, our major role is development of new technologies, processes, so that we can have better energy efficient processes. That is there for especially processing. But at ICR we look at it as a agriculture and food production system. Like we will see holistically. So how we can reduce this in total carbon footprint, energy input, and resource optimization for production, processing, and moving it in supply chain from farm to next level. Like our focus will be mainly from production and post-harvest sector, but we work on many aspects. So that is in particular ICR, but in general, as a R&D institution, they can play this role as a founded network, developing technologies, as well as working as a education and research, training for youngsters, like next generation technologists and scientists
filtration is done by heating. So can a membrane process like with a microfiltration, you can filter out the microbes, and we want to compare these two, like vis-a-vis heat pasteurization. Can microfiltration of milk or fruit juice or sugarcane juice to pasteurize these products? So the ultimate advantage will be without losing the nutrient factors, you can achieve this one. Similarly, if you want to reduce the volume like evaporation vis-a-vis reverse osmosis, with using reverse osmosis, how we can reduce the water content. In evaporation also we do the same thing. So these kind of things, alternative methods, alternative materials, alternative processes, alternative energy sources is one of the areas. But that will be the one of the restricting it. We should bring circularity into this agriculture food production and agriculture and food production, like using all the streams coming out of these byproducts and other things coming out of the processing, going back into the system or regenerative agriculture if you want. How we can add value to this or take it back to soil and into agriculture so that the systems are regenerated. These are broadly how R&D institutions can play a pivotal role in developing these machineries, energy efficient machineries in general. And so regarding the extreme events also, we have some of the technologies, like if you have the frequency of extreme events is increasing. So if you have, let us say, the produce is there in the field, harvested produce like corn is there, when floods are there, storms are there, the produce is how we are having better prediction capabilities are increasing, and our prediction models are becoming finite. So we can take some measures to minimize or avoid these losses, like predicting the produce either in field or in your stores or there, providing proper tonnage or covering it with this. After wet materials, immediately to dry them, we develop a foldable corn dryer, corn cobs dryer is there. So such things we are promoting, and there are many technologies out there. So these are the overview of how research institutions can play a role. Thank you, Dr. Lucia, for briefing about the efforts of the ICR, particularly in development of food processing machinery as well as the storage of farm produce. And you have also mentioned about different methods which are being adopted by different institutes in this sector. Now I will move to Mr. Rana. My question is particularly about how can policymakers and industry leaders collaborate to enhance the sustainability of food processing machinery?
So, when I was thinking about this question, there are three things which come to my mind. First and foremost, of course, if the government can, implement or provide incentives for sustainable practices, in the form of tax breaks or XYZ. Second is, and which I very, very strongly believe in, is fostering industry academia partnerships. Why I say that is because today there is a need for awareness and there is also a need for innovation. So when I say awareness, what are the food grade materials? So even when we speak of stainless steel, I do not know whether we are aware that first of all, how do we define stainless steel? And when we think of stainless steel, the first grade which comes to our mind is 304. But then it's a premium grade of stainless steel. But then there are 4 or 5 other food grade materials like 430, 204 copper, JSLOS, which comes at a much lower price point. And therefore, and these could be cost effectively used, in fabrication of machinery, in food processing industry. So that need of awareness is there. And secondly is innovation. Like, I'll give you an example. approached us, but unfortunately we couldn't provide any cost-effective solution. So finally she moved with the bottles, with glass bottles. So there, if a institute or university like NIFTEM, if they can have a much stronger partnership with like Jindal Stainless, where we come out with various, like stainless steel cans, which I still feel is not so, prevalent in India. We can also have, courses, elective courses at NIFTEM, where we can, each talk about stainless steel. We can have about 1 or 2 credit course. We already do this at some of the IITs and NITs, where we have elective courses on stainless steel, like IIT Kharagpur, IIT BHU, Roorkee. So this is, one aspect which I very strongly feel about. And third is, in terms of auditing and ensuring that, the correct recommendations are followed. I'll give you an example like Delhi Jal Board. Earlier they were using carbon steel made water tankers for carrying potable water. Now what happened was this carbon steel was internally lined with coal tar to prevent corrosion. And the users, they started complaining about the quality. So Delhi Jal Board then, they looked at stainless steel and they went ahead with 304, a grade of stainless steel. And what they found out was the quality of the water improved. Not only that, although the initial cost of fabricating these water tankers was higher, but they saved in terms of the longevity. So, whereas carbon steel water tankers could be used for, 2 or 3 years, these could be used for 15 or 16 years. They could reduce the weight of the water tanker, and that resulted in fuel savings, lesser greenhouse emissions. And of course the maintenance part, the safety of the water, the quality of the water improved. So they moved from carbon steel to stainless steel. But I do not know, or I cannot say with conviction that all other states or all other municipal corporations are using stainless steel for transporting water. In fact, when I do visit some places, I do find water being carried in carbon steel tankers as well. So that is something which the government needs to do. Second is like edible oil. Ideally, edible oil should be transported in stainless steel tankers. But I'm not sure whether all edible oils are being transported in stainless steel tankers. So these are the 3 things which I feel we should focus on. One is incentives for adopting sustainable practices. Second is fostering industry academia partnerships. And thirdly, a strict auditing, strict vigilance, so that the best practices are followed everywhere in India.
Thank you, Mr. Anandi, for briefing about the importance of the academia-industry collaboration also. And now we move to next panelist, and he is Mr. Subramaniam. So my question is particularly related to his company, because they may be facing some challenges in development of
that's coming out. But many of the times during the off season, a miller, a flour miller typically might actually be aiming at the production of the brand because that will be his more important market than the flour. Of course, flour he has to sell, but there would be a more pressing requirement to produce the brand. So you will have very conflicting and confusing requirements like this, and designing for this uncertainty is one of the biggest challenges that we face. Next, the policy recommendation. For this question, I'll divide my answer into a kind of carrot and stick model. Maybe as Mr. Rana also mentioned. One is the line of incentivizing and the other is the line of regulation and making the rules a little more stringent. The incentivizing has to come for the technologies that are more sustainable. That's an obvious statement to make. But I think we've taken some good strides when it comes to alternative fuel sources, or for that matter, even more energy efficient motor. Now it's a part of our guidelines that we'll have to move to IE2, IE3 motors, but there are more energy efficient motors as well. IE4 is also there. Now, how do we use these technologies and then translate the benefit to the customer, also price our solutions, right? This is one of the biggest challenges there. Some kind of an intervention from the government where they incentivize sustainable technologies could be helpful, number one. Number two, we also need to think of incentivizing digitization and food processing. It's very important. I'll again quote a very small example. You all know pulses processing. Hulling is one of the biggest challenges in pulses, right? Especially pigeon pea or even moong dal. It's very difficult to remove the skin of that. Now, if you overdo the hulling process, you end up losing 6 to 7% additional powder. And what is it contributing? It's the protein that we are losing. Right? Pulses have about 20 to 25% proteins depending on which you are choosing. So all this is actually contributing very, very directly to the water usage, land usage and GHG emissions. So how can we reduce this powder generation during pulse processing? By continuously monitoring what's happening, making sure that you're not overhauling your pulses. So digitalization is important. This has to be incentivized. And the last point is learn from economies and markets which have done sustainability reporting in a very systematic manner. European Union, it regulates something that's called Corporate Sustainability Reporting Directive. There are about 50,000 companies today in Europe that are being affected because of this regulation, and they've got a very simple rule. Either you employ more than 500 people, or your asset base is more than 20 million, or you make a turnover more than 40 million. If you satisfy 2 out of these 3 criteria, then you are bound to make your sustainability. Greenhouse gas emission protocol has to be reported. You have to do the life cycle assessment of your products. So this has to, in some shape, come in India. When you buy a pack of flour, a pack of chips, or a bottle of water, you have to know what is the carbon dioxide equivalent that's getting emitted because of your purchase. I think once this happens, we have it for nutritional values today. If we do it for sustainability as well, I think the consumer awareness will increase and the pull from the market, when that increases, the rest of the value chain will fall into by itself. So that's my recommendation.
Thank you. So particularly you highlighted about the incentivization as well as the digitalization. So Dr. Rashia, so number of technologies are being developed by ICR Institute. What are the challenges in scaling up and dissemination of such technology to end user or industry? And you may also suggest some that we can test our technologies on large scale if their setups or their new ideas we can say, test in specified conditions, in control conditions, in research institute. Both ways it should go and the technology should reach the end users effectively. So that is there, and as far as policies are there, we have incentives for promoting these energy efficient technologies like subsidy schemes, especially farm machinery we have, but for some of the processing equipment also we are increasing that component in Department of Agriculture and Agriculture Farmers Welfare, where they give incentives, but you need to have the equipment have to be tested and certified they meet the criteria, capacity and the energy efficiency is there. So then that kind of policies we can have. But what we want is for research institutes, long-term funding commitment should be there. For energy efficiency is everybody's baby. So it is nobody's baby. Everybody talks about, but nobody owns it wholly. So for research institutes, if we want to have activities, maybe government should take some green energy fund or something and allocate that to research institutes. If we have predictable funding requirements, the research institutes can plan their activities and do this one. And for an example I give, like Amul model, like if we can pool these things and because our farms are small size and farmers are there and the production centers are production is segregated, so we have to collect and make clusters or other things like Amul, what they collect at the different centers, chilling and then processing center. Similar things we can replicate. Milk was easy to handle and easy to mix and process it, but for other products also, for many products we can replicate that model. So government should incentivize these kind of things, like they are promoting in farmer producing organization and others to have this kind of thing. But we want the custom hiring and agro-processing centers to be promoted, so that in catchment area the produce is processed and the ownership will be with the many stakeholders. So these are some of the policies that we are talking about the working of the R&D institute and industry together, and also to provide the subsidy on the machinery which are energy efficient.
So I think we are already behind the schedule, sir, and I think the session has already been concluded where the inputs from all the stakeholders from the industry and R&D institutions have been given. I think it was a wonderful session. Good round of applause for the entire panel. Now I will invite the speakers and speakers who join the stage for a group photograph and felicitation. I request Director Jindal Singh Gopal to please felicitate the August gathering. Please. We are having a tea break. If we have any questions from the panelists, I think we can take it over there. So, yeah, please. So, after tea, we will be assembling sharply at 12:15. So, be there at your seats after the tea break. So, I request Dr. Neeraj to please.
Thank you, Dr. Vikil. So, I would request our director sir to kindly felicitate Dr. R.D. Patil, former director, ICR advisor.
Good round of applause for the
I would request sir to felicitate C. R.N. Ramakrishnan sir, Director, CSIR, NIST.
sir, for felicitating the moderator of the session, Dr. C.R. Mehta, Director, ITS, Bhopal.
Round of applause, please.
Mr. Anit Ranaji, Vice President, International Business, Jindal Steel, kindly join us on the stage and requesting sir to felicitate Rana sir. I would request Mr. Shashidhar Subramanya, Head Corporate Technologies Fuller Group. I would request Dr. N.K. Narsaya, EDG Process Engineering ICR, to kindly join us on stage for felicitation ceremony. I would request the audience to please give a big round of applause. I would request Dr. Baljinder Palkaur and Dr. Nitin to kindly join us on stage for group photograph. All the panelists and moderators, please join us for a group photograph. Dr. Winkle. Sir.
Hello. Yes, sir. Yes, sir. Yes, sir. Yes.
Thank you, everyone. So we are taking a quick tea break now. I would request all the members to please be back.